Good morning, good afternoon, good evening, wherever you are. Welcome and hello. My name is Deepak Singh. I've been at AWS for over 12 and a half years. There, I run our containers, Linux, high-performance computing organizations, and the Amazon Open Source Program Office. Some of you may remember me on a stage, a little larger than this one, even had a chandelier at Las Vegas the last couple of years. I was sharing that stage with David Richardson, who runs our serverless org. And in those talks, we talked a lot about how we think about what modern applications means to us at Amazon, how it has influenced the products that we build, the services that we design and make available to you, and quite honestly, how we run our teams ourselves. This year, re:Invent's virtual, so we decided to split up and cover some of the same topics just a little bit differently. So what am I going to talk about? Well, for one, instead of telling you how we run our teams and how we think about software, you learn from lessons that we have learned from our customers, how they gel with our vision, and how those customers are modernizing with AWS and influencing the products that we build, the services that they use, and some of the announcements that you'll hear today. In fact, some of you have already heard them because you heard them in Andy Jassy's keynote a couple of days ago. This talk is going to stay somewhat high level. I'm going to talk about the lessons learned, the patterns that our customers are using, and announce and introduce some new services and products. But there's a number of deep dives from other AWS speakers throughout this conference. At the end, I will link to some of these topics. You should check them out. And quite honestly, check out all the talks on containers, on serverless, on modern application development, on developer tooling. You'll find them very useful. You may find them interesting, or you might actually learn something from them and apply them in your own organizations. Many years ago, I read a series of blog posts, there are 4 of them actually, by a gentleman named Jameis Buck. For those of you who don't know Jameis, he is the author of Capistrano, one of the early core members of Ruby on Rails, and I believe still works at 37 Signals. The title of those blog posts was, "There is no magic, there's only awesome." And there are few blog posts that have influenced my thinking as much as those do. And here's what he argued for in those posts. He said that it's human nature to look at something exceptional and think of it as magic. Another way of saying it is, there's a saying that says anything suitably advanced seems like magic to humans. It's much the same thing. But what Jameis said was it's not magic that separates the exceptional from the mundane. It's awesomeness. And by awesomeness, he meant how we think about the tools that we use, how well we use them, and what do they allow us to do. It actually influenced my thinking in such a way that I kind of paraphrase what he says and tell people around me that there's 3 things I don't believe in: magic, silver bullets, and unicorns. Because when people think about things in those terms, they assume it'll paper over any deep thinking. They don't need to understand what they're building, and they sometimes end up assuming everything is going to be fine, and they learn the hard way that it's not. But what I do believe in, and what Jameis believes in, is awesomeness. And today, I'm going to dig into a whole lot of awesomeness over the next 50 minutes or so. The agenda for today's talk is somewhat simple. We're going to talk about patterns for modernization. These are patterns used by our customers. There are many, many patterns that are out there. We're going to talk about 3. And we'll go into some detail into each one of them. These are strategies that our customers are using to modernize not just their applications, but the businesses too. And quite honestly, it's the business drivers that impact how they think about modernizing their applications. We will take a look at the core building blocks that they're using to modernize, to leverage these strategies, and jump into the cloud, adopting technologies like serverless, like containers. We will talk about how operators and DevOps teams can scale these production environments, how they can get the rest of their org to adopt these new technologies and be successful with them, while maintaining all the guardrails and tooling and compliance requirements that any large organization has to. And last but not the least, to get any developer to adopt what you're telling them to do, even if you haven't figured out the mechanisms to scale it across the organization, those tools have to be exciting. They have to be delightful. And so we'll talk a lot about usability and how you can put all of these together to excite your developers. But let's start with a journey. I'm sure all of you have heard about Vanguard. Vanguard's one of the largest investment management companies in the world. Like many other companies, they want to become faster. They want to move quickly. They want to adopt DevOps, microservices, continuous delivery, all the things that organizations think of when they want to move quickly, when they want to reinvent themselves. But Vanguard had a challenge. They are an old company. They've been around for a long time. Their applications have a traditional tech stack. They are heavily virtualized. We are talking of 30 to 50 million lines of code. They thought a lot about how they could change, how they could move faster, how they could allow their teams to innovate and move quickly while taking care of security, the governance, the compliance required. They're still a large investment company, and they needed to think about that. They ended up choosing ECS on Fargate. Many of you may have seen them talk about this journey at re:Invent last year when Vanguard was, when they came out to talk in Andy Jassy's keynote. And the reason they liked ECS with Fargate was, one, they really, really liked the security model. The security by isolation model of Fargate fit into how they thought about security. Add to that the consumption model, the deep integration with the rest of the AWS services out there, and what did it mean for them? Well, they were able to move much more quickly. They were able to lower costs, so 30% lower cost of compute. It cost them a lot less to build their applications, 30% lower cost to build. And perhaps most importantly, they were deploying 20 times more often than they used to before. So they were able to reduce costs. They were able to build at a lower cost. They were able to deploy a lot more often. And at the end of it, they still were able to maintain the guardrails, the governance, and the integration with the rest of AWS that they wanted to. There's a ton of good content on how Vanguard has leveraged Fargate, and you should go check those out. The Vanguard modernization story is just one. Companies are different, customers are different, needs are different. So let's step back a little bit and talk about the common patterns and strategies that we've heard from a broad customer base. They are divided into some discrete topics, but one of the things I'd like you to remember is there's no clear difference between these. Very often, people are in the edges between these types of patterns, and they pick based on their need at that point of time. And two teams in the same company can pick a different pattern. In the end, my hope is that you're able to take this talk and the other talks that you'll hear at re:Invent this year and identify your own road to success. The one constant we all have to deal with today is change. Just look at the world we live in right now, the environment we are in. Change is everywhere. Customers face unprecedented challenges. But at the same time, they want to move quickly. They want to innovate. Very often, this is the time that they can reinvent themselves, and many customers are. They need to be able to scale quickly to millions of users. I don't know how many of you were sitting after the election in the US and pressing refresh on the New York Times page for a week. I know I was. So your applications need to scale quickly. They need to be responsive. They need to respond in milliseconds, and they're often built on petabytes of data. These are some of the characteristics of modern applications. They include applications that could be web apps, backend services, mobile apps. You could be doing a ton of data processing. Maybe you started adopting machine learning. Our customers have a portfolio of these applications and workloads. When they move to AWS, they have to make a choice for each one. Should they be retained? Should they be retired? Should you rewrite your app? These are all the things that our customers care about. I won't go through every one of these cases, but we'll go through 3 specific ones of those, and we'll talk about that. So what are the questions that we often hear from our customers? They're actually not that surprising. I suspect all of you have asked these. Our goal is to help you go through these questions and make it easy for you to answer them yourself, and based on what you know, choose the right path based on the things that we talk about today, the options that we provide, and the things that work best for your organization. Common questions are, how can I move workloads to the cloud? The assumption is, for most organizations, is modernization and a move to the cloud come together. It may not happen today. It may not even happen tomorrow. But at some point of time, the majority of your applications are going to be running in the cloud. How do you get there? What are the things you need to do today that make success 5 years down the road much more sure shot and fraught with much less pain? The second part is, how do you actually do it? What are the technologies that you use? How do you change your organizations to do that? Very often, and companies, this is actually a conversation that I have with customers a lot, is how does Amazon move so quickly? And they realize, and they've read, that companies like Amazon allow their developers to serve themselves, to build, to be able to run without having to ask too many questions and ask for too much permission, while maintaining all the guardrails that a company at this size needs, because you have compliance needs, you have quality requirements. There's a bunch of things that can drive that. So those are some of the questions that get asked. Then you get into the more specific ones. Should I pick containers? Should I pick ECS? Should I pick EKS? Should I pick Lambda? And we'll talk about that. And last is, at the end of it, are you setting yourself up for change? Because what you know today may not be true tomorrow, and you may have to serve way more traffic, or perhaps in a negative world, serve much less traffic. So I think these are some of the questions that we hear from our customers, and many of the things that we talk to them about how they should think about modernizing, are reflected in these questions and driven by them. So why do you modernize? Well, you want to run all apps at any scale. You want to improve your customer experience, which means you should be able to scale to millions of users. You may not always be having a website that's responsible for election results, but at least in the US, once every 4 years for a presidential election, you will be. And you need to be able to handle that traffic. You need to have global availability and increase the efficiency of your developers. A great example of this is websites where they go down because they have to do some maintenance. That's not fun. As a consumer, that's not fun. It's not fun for the teams that are doing it, because they have to operate it, go down. So they want to be able to work in a world where their applications are always available. And in fact, one of the most interesting parts of the cloud is that your applications can be available anywhere, globally. It's not uncommon for an enterprise to come to AWS and say, we have a well-oiled machine, we are running in our own data centers, but we want to run these applications because of some new regulation, GDPR, for example, in Germany. AWS has regions in Germany. How do we take our existing stack and move that to Germany? And that's very often a question that starts a great discussion between AWS and that company. And then, of course, you go from there, and you end up having more and more interesting discussions as you think about modernization. And as our world becomes much more data-driven, it is super important for us to be able to handle petabytes of data, handle lots of compute, but you need to be able to do it at a much more efficient cost structure. You have to be able to show better ROI, better TCO. Otherwise, it's somewhat pointless. So I've been teasing this for a while. Here are the three things, three strategies that we're going to talk about today for modern applications. We're going to talk about replatforming, and I'll go into all of these in some detail. But essentially, replatforming means you're taking an existing application and moving it to the cloud. And as you can guess, we're going to talk about containerizing as a means of replatforming. We'll talk about refactoring, which is the most fun for me. I mean, if you aren't a software development shop today, if you develop applications, you are refactoring code all the time. Now, how do you refactor code with modern applications in mind? And I'll talk about that too. My suspicion is, for most customers, refactoring is where they spend a chunk of their time. And last is perhaps the easiest one, the most obvious one, which is, I'm building a new application. How can I build this application to take advantage of everything that the cloud gives me? Because you're not encumbered by anything. So we'll talk about that as well. The reality is not so distinct. Depending on who you are, you may be doing all three at the same time. You could have a team here that's replatforming, a team here that's refactoring, and that fun little team in the corner that gets to build new apps all the time and doesn't have to worry about anything. I would like to be that team. It's much easier. And let's talk about these in some more detail. Replatforming is often the first step to the cloud. For an enterprise, it typically is. Just a few weeks ago, I was talking to someone, and the question they asked me was, what's the best way to lift and shift to the cloud? And that became a super interesting discussion about what lift and shift means. You could argue that just taking an application and moving it to the cloud as is a terrible idea. And some people would say there's merit to that. But that's also really complicated. You have to figure out all your dependencies. You have to figure out what application depends on what database somewhere, what processes are in place. So the advice that I give, and what we found works really well for customers, is if they slow down, they think about the things that are really important for them to operate in the cloud. Things like making sure that the identity and access management and identity systems are well aligned with how you do IAM on AWS. Do they have the right control tower, the right organizational sort of guardrails in place so that when their teams start moving to the cloud, they're using tools and talking a vocabulary that they're already familiar with. Once you set them up, you can start lifting and shifting. You could take advantage of a few things that the cloud provides. You have a variety of EC2 instances to choose from, so you could potentially save cost because you haven't had a chance to update hardware in your own data center for a while, or you've been running on a bigger piece of hardware because that's what you had. You could get better security because you have fine-grained permission control, and you can put guardrails around your networks, for example, with VPC. You do have more flexibility. You could choose to say, hey, this application's running on MySQL in my data center. I can run that application on a managed RDS-based RDS MySQL on AWS. It's still MySQL. You're not changing anything, but you're no longer managing a database, which I think everybody can understand is a great thing to do. So a lot of the effort that platform teams in your own data centers, where they spend a ton of time keeping things up, provisioning systems, a lot of that goes away the moment you come to the cloud, because provisioning and maintenance are fundamentally different things, and you have access to a lot more managed services. What we found is that containerization has become a critical part of this lift and shift process. Once you know your dependencies, you can put things in a container. Once you have all these guardrails and tooling in place that I talked about, and there's a small amount of investment up front, you can choose not to do it, but I would suggest you do. You can move your application into the cloud, and that's where you go, and that's where you start from. It works, it's worked for a lot of customers, and it's also helped us evolve how we think about our containers. And I'll talk about that a little bit later on some of the tools that we have that can help you move your applications, existing apps, into the cloud. The second strategy, my favorite one, is refactoring. It's actually I'll step back and talk about my team. Every team at Amazon and AWS that I have been involved with, including mine, start off by building applications as services, not as one big monolith. But at some point of time, even your small service becomes big, and you need to break it apart. For us, the reason we often break things apart, one, is ownership. If you have a small team, we call them two pizza teams, that's responsible for, say, an API or a service, you can continue to operate that service, have a lot of ownership over it, make sure it's amazing, and make sure it has really good contracts with every other service. It helps the organization move faster. It helps you stay out of the way. It helps you deploy more quickly. And perhaps most importantly, when you break services up, it's also improving the resiliency of your application. The term we use is blast radius. And you've probably read all the case studies from AWS, from Netflix, where you want to say that in a monolithic application, or even an application with lots of dependencies, when one thing goes, everything goes. When you break things up into smaller and smaller pieces, you have the advantage that the whole application keeps running even if one component is not. You've probably seen this on the Amazon.com webpage, on the Netflix app. But there's many reasons why you want to refactor. You may have an existing application, and you can pull out some services to take advantage of cloud technologies. There may be some piece of it that you find you can easily move to AWS Fargate or Lambda. Why not? If you can, you should. And it helps you start getting that leg up on moving faster, even with existing applications. As you move more to the cloud, you could take other pieces and start breaking them up. Something could start running on a database like Aurora, or you find they're essentially using a database like a key value store, and you start running that part of your application on DynamoDB. This breaking up of things, whether it's intentional from applications that have been running in the cloud for a while on VMs and are built in a certain architecture, and it growing into smaller, more discrete components, is great. Or if you're an existing application running in your own data center, where it's starting to take pieces of it and running them as independent services. Either way, refactoring gets a ton of benefit from the cloud because you can start taking advantage of the native capabilities that a cloud provides. Managed services, multiple types of databases, more and more abstractions that help you focus on your business, not on the things running underneath. And this is where we find that a lot of our customers choose serverless. I talked about Vanguard and their modernization strategy. This is a great example of where serverless can really help, in their case with Fargate. Our third one is the most obvious one. In the early days of the cloud, this is almost most of the use cases that you saw on AWS was building new applications. Here's the fun part. The application you build today, you'll be refactoring a few years from now because the cloud's going to give you that much more new capabilities. Some new thing, beyond containers and serverless is probably going to come by in 5-6 years. Lambda didn't exist 6-7 years ago, but now it does. Fargate didn't exist 5 years ago, now it does. But when you don't have anything to undo, you're not encumbered by any constraints or previous legacy, you can take advantage of everything that the cloud gives you. You can start if you're a startup, you don't have organizational constraints. You get to pick the way you want to build your org based on how you want to structure your applications. And it's almost reverse Conway's law in some ways. What a lot of our customers have found, especially larger ones, because they do have organizational legacy, is that they build a shared services platform to make it easier for their operators and developers. Some of them will pick a bespoke one. Those usually don't work because they run into barriers, whether they be cost barriers or flexibility barriers or just they don't work for a company and the different business units we have. But the idea of a shared services platform is it gives you standardization. There's a small team of experts thinking through how to bring the cloud and enable innovation. And then you have the application developers who focus on the application, what you need to do to make those applications successful. So again, you have all the guardrails in place. Those are important. You can't forget them. You can't have an application being built and then 6 months down the line or a year and a half, when you're ready to go into production, find out that, oh, no, this doesn't work with our security posture, or it doesn't work with our compliance or governance needs. That's not something you want to do. But the net result is everyone is more productive. Your operational and infrastructure production engineering teams are happier because they have the right level of controls in place. They get to build and innovate. And on the flip side, your business application teams are building amazing applications, and they are not being stopped by the fact that they have now got to think about infrastructure or how its deployment should be done. Somebody's solved that for them. They're just deploying. And a great example of that is a company you all know as well, and that's Snap. For the few of you who don't know what Snap is a company that runs Snapchat and other properties. One of the things they've done as they've continued to grow is they're building new products. And for those products, they launch them as new services. They're using EKS and ECR for them. They're taking their monolithic applications, so there's a bunch of refactoring here as well. And they're doing 2 million transactions per second over that. And this was some time ago, so the number is probably even higher now. And at the same time, the developer effort went down by 77% because of how they build the applications using EKS and ECR. And you've now seen different types of case studies across the whole gamut of company types. They all have some variation of all the strategies that we talked about today. And they are, by and large, today using containers and serverless technologies to build their applications. I see very few people in this day and age. It's not universally true. But by and large, when you're building an application today, definitely in the refactoring and new application case, but increasingly so in the replatforming case, where those are not being built using containers or using something like Lambda or Fargate. So since I mentioned a bunch of products, let's look into the core technologies that you can use to build. One of the nice things at AWS is we start with the foundational building blocks. They're driven by the why. We just talked about all the reasons customers care and want to adopt these strategies, the business needs. We're going to talk about the how now. In the early days of AWS, if you go back and look at any talk from Werner Vogels from 12, 13 years ago, one of our calling cards was, we like taking care of the muck, or stated in slightly better words, undifferentiated heavy lifting. These are things that don't bring you any business value. Managing servers, managing storage, managing networks and operating systems is time consuming, it's expensive, and in 99.9% of cases, or somewhere thereabouts, they don't help you move quickly. They don't solve your business problems. And it's no surprise that the earliest AWS APIs were APIs on top of these pain points. The beauty of EC2, and it was EC2 that really drove it home for a lot of people, including me. I was not at AWS at the time. But I remember the day EC2 got launched, and I remember turning to my wife and saying, you know what? I can now get a Linux machine, and all I need to do is this call run instances. With one CLI call, I suddenly had a server, and all I had to do to get that was swipe my credit card, enter it into a website. And that was pretty cool. It was exhilarating. Today, it doesn't seem that big a deal because we're all used to it. But in 2006, it was a big deal. It was a big deal in 2010 as well, by the way. And in some places and in some companies, it's probably a big deal today. But within a few days of this happening, we had spun up a 20-node cluster. We had some data and some code lying around, and we were processing protein secondary structures. That is pretty amazing. And that was that time. As infrastructure has evolved, as the business problems have evolved, as the technology problems have evolved, and our customers have run more and more workloads and different types of applications on AWS, the definition of muck, the definition of undifferentiated heavy lifting also evolves. The layers of abstraction keep getting built. It's not just about provisioning storage or about provisioning servers. With VPC, you started provisioning networks. With RDS, you started provisioning databases. With things like DynamoDB, you literally had a database that was just an API. And that, being able to take care of that undifferentiated heavy lifting for things that drive little to no value for customers is super important, and everywhere we find it, we try and eliminate it. And containers were a big part of it. The reason containers became popular was one of the most common problems people had, and quite honestly, this was a problem people were trying to solve before containers, is how do you package something and how do you deliver it? Can you do it in a way that's immutable? Because that had become a very popular way of deploying applications. Netflix, very famously, was baking armies, Amazon Machine Images, putting the software on it. Every time there was a change, they'd bake a new army, and that would spin their deployment tooling system. Other people were doing the same. And containers came around and gave people a much more convenient way of doing exactly that. What Docker brought to the table was a really nice user experience on building, shipping, and running a container, because the runtime and registry and the build tooling were all part of the container ecosystem. Over time, as people got more sophisticated, you had to add container orchestration, whether this was ECS, whether it was Kubernetes, whether it was Mesos, which adopted containers from quite well, or even the tools that Docker generated. You suddenly were using this unit that you could run on your laptop, manage all your dependencies, and you were building a lot on top of it. And it made it much easier for people to run their infrastructure, to run their applications on shared infrastructure. It enabled these shared services platforms that I was talking about. And it also allowed legacy applications to get containerized, because you could do it. There's a bunch of container diehards that will say you should have one process per container and that's it. Well, it turns out reality is not that. What people started doing was figuring out what the application was and all its dependencies and using containers to package them up, the code, the runtime, the libraries. And it made it much easier for them to start moving those applications over across the cloud. And while there is no such thing as perfect portability, the container itself was the closest we've ever got to of having a runtime that can be run on a laptop and somewhere else, and you can get a consistent development lifecycle. Now, in reality, it's more complicated than that. But at a starting point, that's why it got so popular. At AWS, we have a fairly vast portfolio of container services. I'll start with the container management tooling, which is Amazon ECS and Amazon EKS. ECS is our AWS-built container orchestration service, and I'll talk about that a little bit in a few slides. And EKS is our managed Kubernetes service, because all of you love Kubernetes, but the part that most people don't like is managing Kubernetes, the control plane, the etcds, all of that. You need to run these containers somewhere, and on AWS we have two ways you can run your containers. You can run them on EC2 instances, or you can run them in serverless containers on AWS Fargate, which, and if you've heard me say this before, is the way to run containers, because running containers on VMs and orchestrating them, it's almost regressive, because you suddenly introduced a whole lot of leaky abstractions that in many ways, when EC2 came, you're taken away from infrastructure. You need a high quality container registry. You can run your own. You can really run any, but most of our customers pick ECR because they like the scale, they like the availability, they like the fact that it just works. And at the end of it, once you've broken all your applications up into little pieces and all of you are talking to each other, you need to connect those applications and services, not just using low-level networking, but higher-level application-level networking. That's where something like AWS App Mesh comes in. It probably means you need some service discovery in there, which is what you use AWS Cloud Map for. There are other tools. We have Lightsail containers. We have Beanstalk, Code Build that fit into this ecosystem. But this is basically what I'm going to talk about today. So we talked a lot about replatforming. How do customers do that? Well, they were figuring it out and doing it the hard way. And to make life a lot easier for them, we built something called App2Container, or A2C. What App2Container does is it makes getting started with containers a lot easier. It looks at your Java or .NET applications, figures out what the dependencies are, and actually builds a container for you. And once you have the container, and it's it will also create some of your manifests, etc. You can then start running them in your own data center or on AWS. You can move very easily to something like ECS or EKS once you've started with App2Container. App2Container is relatively new, but you have a good idea, gives you good insights into where we are going with it. And it's explicitly targeted today at that replatforming case, where you're taking existing applications, you want to containerize them as a step into moving your applications to the cloud, and over time you might start refactoring them, or you might evolving them into more modern applications. But this is the place to start. Many of you like Red Hat OpenShift. One of the things that we hear a lot from customers are they like the fact that OpenShift, they have an existing relationship with Red Hat. They like the high-level abstractions that OpenShift brings to something like to Kubernetes. And perhaps most importantly these days is once they've invested in something like Red Hat Enterprise Linux, once they've invested in other Red Hat software or IBM software, OpenShift is a great way for them to run those applications anywhere they want to, taking advantage of all the modern practices that OpenShift has underneath it by default. So instead of saying, hey, yeah, AWS supports OpenShift, Red Hat has OpenShift dedicated or OpenShift Online, we decided to collaborate with Red Hat and build a jointly operated service called Red Hat OpenShift Service on AWS, which we announced a preview for at KubeCon just about a couple of weeks ago. And the whole idea of OpenShift service on AWS is it feels to you like OpenShift as an AWS service. You come to the AWS console, you start using it, you get billed through AWS, you can call up by AWS for support. If there's more complicated things, if you're an existing relationship with Red Hat, you can go straight to Red Hat. But the idea is that this is going to, over time, evolve to integrate even more deeply with the rest of AWS. So the things you like about AWS and you wish you could use with OpenShift more natively, you'll be able to do that as well. So I'm super excited about how our customers use this. And we already have some enterprises that are chomping at the bit to adopt OpenShift on AWS. The other great part of the cloud is all the compute options that you get. I used to be on EC2 for many, many years, and I used to specifically work on EC2 instances. So you can, if there's a million instances, I take some of the blame credit depending on your point of view. But the great news is you have the plethora of EC2 instances that you get. You now have Intel-based instances, AMD-based instances, and most importantly, Graviton or ARM-based instances. And if you're a company that's thinking ahead, you've seen the performance and capabilities that Graviton gives you, containers actually make it a lot easier. You have multi-architecture images that you can store on a registry like ECR, and you can go if you have code that runs on ARM. Or you could choose to run on Fargate, run it natively, without having to think about instances, without having to think about servers, without having to think about clusters. You get the isolation model. And in fact, our customers like Fargate so much that today, if you're more than half of every new customer that chooses to run containers on AWS picks Fargate. And that number is accelerating. About a year ago, that number was about 40%. Now, it's over 50% and it's growing. Most of them come through ECS, but many of them come through EKS as well. But the key message is it's pretty clear, and that's what we hear from our customers, that they really, really like the model that Fargate gives them, which is, I have a set of containers, I want to run them, I want to run services, and do not want to think about cluster management. I do not want to think about what instances to pick. which applications I want to run on which cluster, and so on. And it shows in the growth. A great example of a customer that's adopted Fargate is Samsung. Historically, they had many administrators and operators that were dedicated to managing their web services for the Samsung Developer Portal. What they chose to do was move to Fargate, and so they significantly reduced their administrative needs. They saved cost at the same time because while an individual Fargate SKU, if you want to call it that, if you look at an equivalent EC2 instance, Fargate's a little bit more expensive, but there's many, many more. You don't have to exactly the right sizing is much easier. And by the way, for services that go up and down, it's much easier staying within the Fargate construct, and you end up saving costs. And at the same time, your developers are that much more efficient. So you combine all of that, it's a win-win for most people running on Fargate. They were able to migrate super easily, and their operational efficiency improved as well. So they were able to get wins in every area that they cared about. And that's the foundation of the Samsung Developer Portal today. And they're just one of many examples of customers that have adopted Fargate and got wins on cost, on operational efficiency, on developer efficiency, and that again also is driving a lot of how we think about what does serverless containers mean, the serverless compute in general. So what are the other architecture and infrastructure choices people have to make? On AWS, there are many, many options. It ends up depending on the kinds of decisions you want to take. You have options of many storage resources. You could choose EFS. And in fact, for containers and serverless, now that Lambda and Fargate both support EFS, we see a ton of adoption of EFS because you want a shared file system to store data between all the containerized tasks or pods that come in and out. Because the life cycle of those tasks and pods can be very short, but the application is long-lived. For people who care about other kinds of characteristics, they may choose EBS, they may choose FSX. We see all of that. I've mentioned Lambda often. One of the most fun parts is that people building modern applications tend to pick Lambda and containers, even AWS services that we build. A great example of that is AWS Batch, which is a service in my organization. Its front end is all serverless, API Gateway and Lambda. Its back end is ECS. And that's not an uncommon architecture. You have to think through how you want to secure your applications. You'll be using things like IAM, CloudTrail. You want to monitor it with things like CloudWatch. And you have to start thinking about how you want to do your networking. You could start off with simple load balance services, but over time, you probably want something like a service mesh to manage communication between all these services, to manage security between them. And it's requirements like that that end up driving hours. So for example, today I'd like to announce that in Q1 of next year, and you can go to the AppMesh roadmap and see where we are with this, we're going to add MTLS-based security into all AppMesh-based communications. It's been a major ask for customers. You start using a service mesh because you want to manage traffic. You continue using service mesh, and you get excited about it because you can also use it to secure your traffic. And those are the kinds of capabilities that we'll continue driving in. And in this particular case, this is coming soon in Q1. You can already run it in preview. I published a blog post about a month ago on how you should think about a container orchestrator. One of the most common questions we get is, should I pick ECS or should I pick EKS? And the fun part is, and I guess this is where it's been easy for us in some ways, is we've learned that from our customers. They've told us why they make the choices that they make. They like the powerful simplicity of ECS. And what I mean for powerful simplicity is it's just a control plane that lets you run containers on EC2 instances of Fargate. You get to use the rest of AWS. You don't have to think about too many options because for load balancing, you're using ALB. For networking, you're using VPC. For logging, well, there you have some choices, but we've made it simpler. But your defaults are going to be CloudWatch, and so on and so forth. But there are many others who want all the flexibility and capabilities that Kubernetes gives them. They want to be running it on premises in their own data center. They want to bring the same practices onto the cloud, or they start in the cloud and they want to take some of those own practices back to their data center, or they want to integrate with a wide ISV ecosystem. Those customers pick Kubernetes, and on AWS, they'll pick EKS. So they like the open flexibility of EKS. They love the powerful simplicity of ECS, And what it means is those customers have helped us evolve our roadmaps in different directions based on the reasons and choices that they're making. And I think and hope over time, it'll make that decision even easier for you, because you'll have a set of capabilities or requirements, and you'll pick the tool that fits those requirements best. And the best part is, in many organizations, they run both. So now comes the fun part. Over the last year, the definition of what the AWS cloud is has evolved. So far, every time I've said cloud, I mean a big AWS region like US East 1 or US West 2 or our Frankfurt or Tokyo regions. These are regions with multiple availability zones. There are multiple data centers, and you can run these highly available applications with all the AWS services available to you. Over the last year and a half, couple of years, we've launched Outposts, which allows you to take AWS infrastructure and run it in your data center. You can choose AWS Wavelength, which is taking that infrastructure and running it in a telco edge, or AWS Local Zones, which is sort of a localized version of an AWS region, like we have one in Los Angeles for if you want to be close to other media companies. So effectively, now we have AWS regions, local zones, Wavelength, and Outposts. But guess what? Our customers still run applications on their own infrastructure. Very often, they may run it next to an Outpost, but they have a lot of applications that are running. They have infrastructure floating around. They can't just throw it into the drink, or they may be in a location where just the rest of them are not options. So what do you do there? Well, I told you that our customers love ECS because of its powerful simplicity. And the way ECS runs across all of these is you still have the same control plane. You have the ECS control plane, you have the same APIs, and you just point it to different types of capacity. That capacity could come from an EC2 instance running in an AWS region. It could come from an EC2 instance running in an Outpost, a Wavelength, or a local zone. Or it could be AWS Fargate. You could choose to run on Spot. You could choose to run on demand. That's up to you. It isn't that hard to imagine a world where the definition of capacity could be any capacity. So you've probably heard Andy announce it, but I'm going to say it anyway. I'm super happy to announce Amazon ECS Anywhere. And what it means is you bring capacity to AWS, to ECS, and ECS will run containers on that capacity. And the best example of that is this demo that, if you haven't seen already, you will, from Massimo Referre, where he's running ECS tasks on Raspberry Pi in his apartment, or something like that. The idea is you don't care. You get capacity. You bring some sort of compute capacity to ECS. All you have to do is run the ECS agent, and you're off to the races. Now, you remember, this is running from the ECS control plane, running in the AWS cloud, but it gives you this wonderful distributed architecture that you can use. And because of what we've heard from our customers about how they want to use this tooling and API, moving from one capacity type to another is simply a deployment. You could start off in your own data center, switch to an Outpost, and switch to an AWS region, and all of it would just be a deployment option. And it's as easy as that. This is just the start. We have a lot of plans for ECS Anywhere. I'm super excited to hear what how all of you are going to use it and what kind of feedback you're going to give us. But in the end, what you have now is taking ECS and just being able to run it on whatever capacity you want to bring it, regardless of where it is. What about Kubernetes? I think we spoke about the fact that many people pick Kubernetes because they want to run it in their own data centers. So how do you run EKS outside of other regions? Our customers have workflows and application portfolios that span AWS and on-prem. Well, for them, the first thing we decided to do was, and it's available today, you can download it and run it, is Amazon EKS Distro. This is the same distribution of Kubernetes that underlies Amazon EKS that we are running in AWS today. It's upstream Kubernetes with add-ons and defaults and configurations that we use to run EKS. So we have an opinion of how Kubernetes should be operated, and you get the same when you take EKS distro, you can download it from GitHub, and run it inside your own data centers. But we want to take that one step further. You can all get the distro. What that gives you is the same bits, but we also have strong opinions on how Kubernetes gets operated and the tooling that should accompany it. One of the things I didn't point out earlier was ECS Anywhere is going to be available in Q1. We are announcing it today. You can see the demo, and very soon we'll open up previews, but availability will be first half of 2021. Almost forgotten which year we are in these days. The same is true for EKS Anywhere. In the first half of 2021, you will start seeing capabilities that we'll provide to you that help you operate these clusters wherever they're running. And you can then get a single pane of glass, a single view into all of these clusters. So you are starting with the same core bits, and then you can add to it with all the operational tooling that EKS Anywhere gives you, regardless of where your applications are running. You can connect to AWS for updates. You can run your Kubernetes apps consistently. With EKS Anywhere, you don't actually have to be connected to AWS to run your applications. So there's a lot of interesting workloads that you can run with this new capability that'll be available to you next year. Here's the fun part. You get to pick the same reasons and advantages that people have to pick ECS or EKS, the same benefits that I talked about earlier. The powerful simplicity, the flexibility, all apply here. And I'm super excited again to see where customers take this and what kind of capabilities we end up building over the next few years, because I'm sure we learn a lot. The EKS Anywhere story is actually not complete without talking about the next two features, one of which is EKS add-ons. These are packages that are useful in running Kubernetes. We use them on AWS that we will patch and maintain for you. So whenever you spin up an EKS cluster on AWS, for example, you can pick the add-ons that you want to add to it. We are starting off with just one or two, but over time there'll be more. These are Kubernetes components. And then you know that you're getting one that's been qualified, that's been patched, that runs with your Kubernetes clusters on EKS. So that's a pretty important one. And last one is the EKS dashboard, which is the single pane of glass that I was talking about. You can use it just to monitor your clusters on AWS, but you can also use it to monitor clusters running anywhere that you might be running your Kubernetes clusters. So again, this is going to evolve over time. I'm super excited to see how people use these capabilities and what kind of add-ons you want. So you should tell us which are the add-ons that you care about once you see the initial list and the ones that we plan to build. In general, the vision is a simple one, and it's well reflected by this quote from Capital One. Capital One was very early in adopting containers. In the cloud in general, sticking with our theme of financial services companies, but they've done a lot, and we've learned a lot from them. They want to be able to run their apps with the same consistent controls everywhere. They want to give their teams the same benefits, whether they're running on AWS, whether they're running in the cloud. And to do that, they've built this amazing platform, and they use different types of container services as required for their applications. I'll encourage you to check out their case study. But the good thing is their goal is to enable their DevOps teams, to give them the right building blocks so that those teams can enable the rest of their company, the application developers. And that kind of mindset is what we see from a lot of our customers, the really successful ones. So this is a great segue to how do you, once you've got all these building blocks, once you've got all these technologies, how do you then help your organization or company adopt them at scale? People have built all kinds of internal tooling to do it. Their end goal is they want to create a developer platform. At Amazon, we have a team called Builder Tools, which has a very simple goal. Their goal is to allow developers at Amazon to build and deploy without worrying about the underlying infrastructure. The best practices are codified in the tools built by the Builder Tools team. Many of our customers, Capital One's a great example, have similar organizations that build these shared services platforms that allow their developers to run quickly. They build the right abstractions. The challenge is it's hard. And what we found was our customers doing the same thing again and again, either succeeding, but in many cases, having a really hard time, and they came to us for help. And the good news is we've seen what customers have done with ECS and EKS, with Fargate and ECR over the last few years. We understand, and they told us what they needed because they were very clear on what the requirements were. At the same time, they wanted to make sure that they had the right guardrails and organizational governance in place. So, once again, you can call them SSPs, that's the term that we use. But what is a shared services platform as I talk about? It's basically something that your developers can come to. It's self-service. You know that if they're choosing something from there, it's going to run in the way that your organization will approve. You can bring new technologies there without having all your developers becoming experts in the technology. If you have new ways of deployment, you can put them in there without developers actually having to figure that out necessarily on their own. And so it allows these organizations that have an operational team or a platform engineering team and a development team, or just two sets of developers wearing different personas, to actually move quickly. And we tend to see it mostly at larger companies. And to support that, I'm very happy to announce in preview AWS Proton. What is AWS Proton? We think it's the first fully managed deployment service for container and serverless applications. We are not trying to solve every problem in the world. We are trying to solve the problem of people who want to modernize their applications with containers and serverless. It gives developers a super easy way to deploy their code that enforces architecture and security standards. So they can move quickly. They are just coming to the self-services portal, picking up the approved application patterns, and just running. And your DevOps teams, your platform engineering teams, your production engineering teams, whatever you call them at your company, they are the ones who are building these application patterns or stacks that define everything that's needed, whether it be the control that you need to put in place, what kind of code repositories you're allowed to use, what does the architecture look like, what code pipelining software are you allowed to use, how do you do observability. Proton ties everything together. It coordinates all the elements to it. So anytime there's a change in stack because you made a component change, it rebuilds everything, your infrastructure, your deployment pipelines, your monitoring, and your developers don't have to worry about it. And as an operator, then you have visibility into everything that's running, who's running what, everywhere. So the developer, all they're doing is pointing to GitHub and picking the pattern that their application needs, and then they can run. We think Proton is going to change the way many of our customers build these shared services platforms. We think it's going to have a deep impact on their agility. And it's in preview today. It has small set of integrations and small set of tools that it supports right now. By the time we go GA next year, that will be much richer. And you should be able to pick how you want to define your application stacks as infrastructure as code, and Proton is strictly infrastructure as code based. It's strictly immutable deployments, or at least for now. You can pick which code pipeline. Today it's code pipeline, but in the future we'll support other ways to deploy software. And you can pick whether you want to use Lambda, ECS, or EKS, and then you can choose from one of many collaborators who help you run your monitoring tools. You can choose CloudWatch. You'll be able to pick from others as well. And I think that pattern is what makes Proton super exciting. But talking about observability, there's other tools that we've built over the last few years to help organizations simplify how they get this visibility into their applications. The first thing we built was FireLens, which is logging through FluentBit on ECS. We now have it for EKS as well. It just makes log shipping that much easier, and you can send it wherever you want to. You can send it to S3, you can send it to CloudWatch, you can send it to one of the many collaborators that we have, whether it be Sysdig, Datadog, or Symologic. We also have invested heavily in OpenTelemetry and now have services for Prometheus and Grafana. You can leverage basically the entire toolkit that you have to run your applications to get the right level of visibility into them. And this integrates really well into the rest of our services. So whether you're using ECS or EKS and now Proton, you can take advantage of the tools that we provide and integrate into the observability tools that you like using, because people can get pretty religious about the observability. The last part is putting it all together. I like CLIs. Some people like consoles. But in the end, the goal is the same. Let's abstract away the developer pain. Building applications is hard. You want people to think about it less and less, and you want them to focus on creation, on innovating, and be more productive and agile. For them, the starting point is many ways of sharing container software. We have Code Artifact, which is an artifact repository for all your code types. And then we have ECR, which is your private container registry that's used. There's billions of image pulls happening on ECR today. And now, we pre-announced this about a month ago, we are announcing ECR public registry. So anyone can publish images to ECR. There's a gallery where you can go and search for these images. And you don't even have to be an AWS customer. You can pull those images. If you are an AWS customer, you have additional benefits. You get You can use them with ECR. You can use them with other AWS services in the future with AWS Marketplace to monetize your registries. But the idea is that you have a really, really easy way of publishing images and consuming them. We also give you ways to model your applications, whether you're using AWS CDK, which is an imperative way to define your app, or using the serverless application model, which is built in a model very similar to CDK, or if you're building front-end sites with AWS Amplify. In the end, our goal is to give developers the tools that they need to define and model their apps. There's no one-size-fits-all. Developers are different. We want to make sure that they have the options available to them to move as quickly as you can. And in fact, we can now, there's a specific version of CDK for Kubernetes that's now a sandbox project in the CNCF. So that model is definitely very popular with our customers. And on top of that, we end up building domain-specific languages or interfaces that help people, developers in particular, use all of this. And the one that I like talking about is Copilot. Copilot's a CLI. It was originally written for ECS, but it's evolved quite a bit from there. The whole idea is that you can initialize a project, define it, define a deployment system, and you can run things, all using a command line. So, init, deploy, release your software. And I would argue that if you're an ECS customer today and you like CLIs, you should be using Copilot. It's by far the best and most powerful way to do it. But some of our customers, many in fact, like using Docker. So we started talking to Docker about what we could do for our mutual customer base who love using Docker Desktop or Docker Compose or the Docker CLI. And we ended up partnering with Docker to make it super easy to start with Docker Desktop, use Docker Compose, and have running services in ECS and Fargate. And we have all kinds of plans and ideas together on how we can take this forward. But we've already seen the excitement that our customers get from using the tools that they love, like Docker, with AWS services. So over the last 45 to 50 minutes, we've talked about patterns that our customers are using to modernize. We are talking about all the tools and building blocks that are available to them. We've talked about new tools and new services that help our customers modernize even more. They'll help you adopt the cloud, adopt containers, adopt serverless at speeds that you never could do before. But we're just starting. We're expanding ECS and EKS to any infrastructure. We are starting to think about what are the right abstractions for our customers that they can adopt and come into that fits the needs of their organization. If you want to run VMs and orchestrate containers on them, you can do so. In fact, now you can do so on your infrastructure. But I think our goal should be further abstractions. I think the muck that we have to deal with, the undifferentiated heavy lifting that we have to deal with, has only gone up the stack. What used to be yesterday's muck has been long forgotten, and we've added new undifferentiated heavy lifting. Today, we are thinking about clusters, we are thinking about networks, we are thinking about how to organize many clusters. I think that's regressive. Tools like Fargate, services like Fargate, help you take all of that away. And it's only one of the ones that we're talking about. It really excites me that our customers tell us in no uncertain words what they want to accomplish. This talk today talked a lot about patterns that they're using to modernize. Tomorrow, there may be new patterns. So we should keep talking about what those patterns are, how we can help you move faster. And in the end, we want to help you lower your costs. We want you to become more agile. And we want to help you transform your businesses. There's a number of talks that'll go into more detail than I did today. We talked at a high level about all the exciting things that are happening in the world of containers. We talked about companies that are transforming their applications, transforming their businesses, however big they are. They could be startups, social media companies, or some of the largest investment companies in the world. If you go through these talks and all the other ones that you will see, hopefully you'll get some new insights into how you can build applications at your companies, how you can transform your organizations, and how you can modernize your infrastructure. Let's go build.